You are watching channel Number Collage. Through this channel, we make sincere efforts to make you understand and like mathematics in a simple and easy manner. We need your cooperation in this regard. In this video, we will understand about similarity of triangles. But before that, let us understand what are similar figures. Similar figures are those figures which have same shape but different sizes. For example, triangle ABC and triangle PQR have same shape but different sizes because triangle ABC is bigger than triangle PQR. There are specific conditions required to make two triangles similar. Let us see what are those conditions. First, let us understand what is one-to-one correspondence between the vertices of two triangles. In triangle ABC and triangle PQR, triangle ABC and triangle PQR, one-to-one correspondence between the vertices is written as A corresponds to P, A corresponds to P, B corresponds to Q, B corresponds to Q, and C corresponds to R, C corresponds to R. It also means that side AB corresponds to side PQ, side AB corresponds to side PQ, side BC corresponds to side QR, side BC corresponds to side QR, and side CA corresponds to side RP. Now we will understand what are similar triangles. Consider triangle ABC and triangle PQR. When can we say that these two triangles are similar? There are two sets of conditions which need to be satisfied before we can call these two triangles to be similar. So, in triangle ABC and triangle PQR, for one-to-one correspondence ABC and PQR, if the first set of condition, number 1, angle A equals angle P, angle A equals angle P, angle B equals angle Q, angle B equals angle Q, and angle C equals angle R, angle C equals angle R, and the second set of condition is AB divided by PQ, AB divided by PQ equals BC divided by QR, BC divided by QR equals CA divided by RP, CA divided by RP. Then we say that triangle ABC is similar triangle PQR, and we write it as triangle ABC similar triangle PQR, where this sign is used for similarity. Now we will understand a very important theorem on similarity of triangles known as basic proportionality theorem. The theorem states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Let us draw the figure. Now in this triangle ABC, if a line is drawn parallel to one side of a triangle, so let us draw a line DE parallel to one side BC of this triangle ABC. This line intersects the other two sides in distinct points. Now this line DE intersects the other two sides, that means side AB and side AC, in two distinct points, that is point D and point E. If such is the case, then these two sides, the other two sides, which means side AB and side AC, are divided in the same ratio. That is, AD divided by DB equals AE divided by EC. In triangle ABC, if line DE parallel side BC, line DE parallel side BC, then we have AD divided by DB, AD divided by DB equals AE divided by EC, AE divided by EC. So this is about basic proportionality theorem. Now we will solve a problem based on basic proportionality theorem. In triangle ABC, if line DE is parallel side BC, then find EC. Let us draw the figure. In triangle ABC, line DE is parallel side BC. We have to find EC. Now in this figure, AD is 1.5 cm, DB is 3 cm, AE is 1 cm, and EC is what we have to find out. Now in triangle ABC, line DE is parallel side BC. Line DE is parallel side BC. Then according to BPT, that is basic proportionality theorem, we have AD divided by DB, AD divided by DB equals AE divided by EC, AE divided by EC. Now we will substitute these values here. So AD is 1.5, DB is 3, AE is 1, and EC we have to find out. So first we will cross multiply. So 1.5 EC will be 3. So EC will be 3 divided by 1.5. Now 3 is twice of 1.5. So the answer will be 2 cm. So here EC will be 2 cm. Now we will understand converse of the basic proportionality theorem. The theorem states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Let us draw the figure first. In this triangle ABC, one line DE divides the two sides, that is AB and AC, in the same ratio. Okay, so this is the condition. So in triangle ABC, line DE divides side AB, line DE divides side AB and side AC, such that AD divided by DB equals AE divided by EC. That is, this line divides these two sides in the same ratio, because these two ratios are same. Then we can say that according to this converse of basic proportionality theorem, line DE parallel side BC. In triangle PQR, line EF cuts side PQ and side PR. Find if line EF is parallel side QR. Let us draw the figure. In triangle PQR, line EF cuts side PQ and side PR in two distinct points E and F. We have to find whether EF is parallel to side QR. PE upon EQ. PE upon EQ is 3.9 divided by 3. Here 3 ones are 3, 3 threes are 9. So PE divided by EQ is 1.3 and PF divided by FR. PF divided by FR is 3.6 divided by 2.4. 12 twos are 24 and 12 threes are 36. And 3 divided by 2 is 1.5. Now here, since PE divided by EQ, which is 1.3, is not equal to PF divided by FR, which is 1.5, according to converse of basic proportionality theorem, we can say that line EF is not parallel to side QR. Line EF is not parallel to side QR. In triangle PQR, line EF cuts side PQ in E and side PR in F. Find if line EF is parallel to side QR. Let us draw its figure. In triangle PQR, line EF cuts side PQ in E and side PR in F. We have to find out whether line EF is parallel to side QR. Here, PE divided by EQ is 4 divided by 4.5 and PF divided by FR equals 8 divided by 9. 2 4s are 8 and 9 divided by 2 is 4.5. Here we observe that PE divided by EQ, which is 4 divided by 4.5, equals PF divided by FR, which is also equal to 4 divided by 4.5, and hence, according to converse of basic proportionality theorem, we say that line EF is parallel side QR. In the given figure, DE parallel AC and DF parallel AE. DF parallel AE. We have to prove that BF divided by FE equals BE divided by EC. BE divided by EC. Now, in triangle ABC, we have DE parallel AC. Therefore, we can apply basic proportionality theorem and write BD divided by DA equals BE divided by EC. BE divided by EC. And in triangle ABE, the small triangle, DF is parallel AE. DF is parallel AE. So, by applying basic proportionality theorem, we can write BD divided by DA, BD divided by DA equals BF divided by FE. BF divided by FE. Now, in these two ratios, the left hand side is equal. Therefore, we can equate the right hand side. So, we will write BF divided by FE equals BE divided by EC. And this is exactly what we have to prove. See here, the same statement we have to prove. In this given figure, DE parallel OQ, DE parallel OQ and DF parallel OR, DF parallel OR. We have to show that EF is parallel QR. EF is parallel QR. First, in triangle OPQ, we have ED parallel QO. ED parallel QO. So we can apply basic proportionality theorem and write PD divided by DO, PD divided by DO equals PE divided by EQ, PE divided by EQ. And in triangle OPR, we have DF parallel OR, DF parallel OR. So we again can apply basic proportionality theorem and write PD divided by DO, PD divided by DO equals PF divided by FR, PF divided by FR. Now, in these two ratios, the left hand side is same. So we can equate the right hand side. Therefore, we will write PE divided by EQ equals PF divided by FR. According to the converse of basic proportionality theorem in triangle PQR, we can say that EF is parallel to QR. EF is parallel to QR. In this given figure, it is given that A, B and C are points. A, B and C are points on OP, OQ and OR. That is, A is on AP, B is on OQ and C is on OR, such that AB is parallel PQ, AB is parallel PQ and AC is parallel PR. AC is parallel PR. And we have to show that BC is parallel to QR. BC is parallel to QR. First, consider in triangle OPQ, we have AB parallel PQ, AB parallel PQ. So we can apply basic proportionality theorem and write OA divided by AP, OA divided by AP equals OB divided by BQ, OB divided by BQ. Next, in triangle OPR, AC is parallel PR, AC is parallel PR. So here also we can apply basic proportionality theorem and write OA divided by AP, OA divided by AP equals OC divided by CR, OC divided by CR. Now, in these two ratios, the left hand side is equal. Therefore, we can write or we can equate the right hand side. So we will write OB divided by BQ, OB divided by BQ equals OC divided by CR, OC divided by CR. This is going to be in triangle OQR. See here, in triangle OQR, we have OB divided by BQ equals OC divided by CR. So, according to converse of basic proportionality theorem, we can write BC parallel QR. ABCD is a trapezium in which AB is parallel DC and its diagonals intersect each other at the point O. Show that AO divided by BO equals CO divided by DO. Let us draw the figure. In this figure, ABCD is a trapezium in which AB is parallel DC, AB is parallel DC and diagonals intersect each other. Diagonal AC and diagonal BD intersect each other in point O. We have to show that AO divided by BO, AO divided by BO equals CO divided by DO, CO divided by DO. We have to prove it by using basic proportionality theorem. So first we will draw EF parallel to AB as well as to DC through O. So through O we will draw segment EF. Now in triangle DAB, EO is parallel AB. EO is parallel AB. So therefore we can apply basic proportionality theorem and write DE divided by EA, DE divided by EA equals DO divided by OB, DO divided by OB. Now in triangle DAC, EO is parallel DC, EO is parallel DC. So here also we can apply basic proportionality theorem and write AE divided by ED, AE divided by ED equals AO divided by OC, AO divided by OC. Next we will write reciprocal of these equal ratios. So we will write ED divided by AE, which is the reciprocal of this, and OC divided by AO, which is the reciprocal of this. After that we will rewrite these two equal ratios as, we will write ED as DE and AE as EA. Now here we find that in these two statements the left hand side is same. Therefore we can equate the right hand side. So we will write DO divided by OB, DO divided by OB equals OC divided by AO, OC divided by AO. Next, in order to reach this statement, we only have to interchange these two terms. So in the next step we will write AO, in place of DO we will write AO, which is this. Now we will write OB as BO equals, we will write OC as CO, and in place of AO we will write DO. Now this is what we have to prove. See here, AO divided by BO equals CO divided by DO. So we have proved this. So this is about introduction to similarity of triangles. If you liked this video, please click like and share this video to the 10th class students and their parents. Subscribe this channel to get more simple videos on mathematics which will help you in one way or the other. Thanks for watching. Have a nice day.